Okay, this lesson still continues with dealing with polynomials and just looking at some more things about polynomials and their characteristics. The first thing we're actually going to do is go back and look at some factoring, which you had dealt with some factoring back in chapter 4, so a lot of the same things that I had told you then. Now, it asks that you are to write this polynomial in factored form. Now, this I've just said, remember to check for your GCF first. So, when you start working any of these factoring problems, check to see if any of your terms have something in common. All right, so looking at this first example here, if you look at each of these terms, you do have x's in each term. You've got 3 x's here, 2 x's here, 1 x here. So the most x's that you have in common would just be 1, okay? Because, I mean, that's all that this last one has. So first of all, we're going to factor out the x. So if I factor an x from x cubed, I'm left with x squared. And then I would be left with minus 7x minus 18. So you're just taking an x out from each one of those. Now, what I'm left with inside my parentheses will actually factor another step. This goes back to the factoring that we had done before also with a trinomial. So your x squared, that's going to be x times x. Now with 18, of course, you've got some choices here. You could go with, of course, 18 times 1, 2 times 9, 3 times 6. But remember, you're trying to find the combination that'll give you the -7. So that's going to be the 9 and the 2 that you need to go with. And if you recall, this last number being negative means that I've got to use different signs. In order to get a -7, I need to have a -9 and a +2. So you actually did some of this with greatest common factor first and then the other step of factoring. A lot of the times in chapter 4, your greatest common factor happened to be just a number, where in some of these cases you're going to actually see variables. Okay, a couple more examples of factoring. Okay, the first one that I have here, again, check to see if you have a GCF, which you do. You have an x that's in common to each of these terms. So I'm going to factor out the x, which will leave me with x squared minus 36. Now, I do have another step of factoring that I can go here. Not the same process that I used a while ago, because a while ago, remember, I had 3 terms, and this time I only have 2 terms. This is what we referred to, if you remember, as a difference of squares, because remember 36 is considered to be a perfect square because it's 6 times 6. So when you're factoring a difference of squares, you're still going to have 2 sets of parentheses. The x squared is still x times x, but you have to use 6 times 6. You don't even worry about all of the other ways that you can multiply and get 36. You have to use the 6 times the 6. And you always have opposite signs, 1 plus sign and 1 minus sign. So this would be the factored form for that second example. All right, for number 3. Okay, so kind of similar to what we had a while ago. I do have an x in common, but this time I also have a 3 that's in common. So my greatest common factor is 3x. So I need to factor that from each term. So from this first term, that would leave me with 3x squared. My middle term would be 2x. And the last term would just be 1. So since that whole term happens to be my greatest common factor, I still do have that understood 1 left in that slot. Okay, so now let's see if this will factor another step. Now, I don't have a choice with my first term but to go with 3x times x. And my last number being a 1, I don't have a choice there but to go with 1 times 1. Now, if you remember what I had told you to do, like in this case, this is where we need to make sure that we get the +2 in the middle. So I would multiply the 2 on the outside edges, so that's a 3x. If I multiply in the middle, I get a 1x. and I need to end up with a 2x. In order to get a positive 2, I need the 3 to be positive and the 1 to be negative, because if you do 3 minus 1, you do get a positive 2. So the 3x times the 1, see, that needs to stay positive. So a positive 3x times a positive 1 will give me the positive 3x. I need to put my minus sign here because then I would have a negative 1 times x, which would give me this negative 1x. So this would be the correct factored form for that example.